Hey, how's it going today, everybody? This is Mr. Myesis. I'm here with you today, and we are going to go over, I'm going to go over and you're going to listen. I guess that's what happens on YouTube. But I'd like to just talk about how to do a one proportion z-test, not test, scratch that, a one proportion confidence interval. So we're going to look at a confidence interval, how we would do a one prop z interval in Geogebra. Again, we use Geogebra a lot in my class, so I thought I'd just throw some videos up here on how to use Geogebra. So we're going to look at the one prop z interval, and then I'll just talk about how to interpret the interval. The most important thing, there are two most important things I can say about intervals right now that I would at least like my students to know. And that is, one, how do you interpret the interval? And two, how do you interpret a margin of error? Like, what is a margin of error? And three, I said there were two things. I mean, there are three things. What does it mean to be confident? Like, what? Well, I'm confident, I like to think, but what does it mean to have like 95% confidence? What does it mean to have 90% confidence? So I'll talk about a little bit about that when I get to the actual interpretation. Okay, so let's take a look at a problem that I have from a previous video. So if you watch this video, you'll have seen this problem in there, and I'm just going to use this. So I've got it here. Let's suppose we have 5% of 200 students that are randomly selected at CSU Stan, which is where I work, said that they owned a pet. So we're going to go and create and interpret a 95% confidence interval. So let me just talk about what it means to have a 95% confidence interval. So 95% confidence means that if we created 95% confidence intervals using a similar sample of 200 randomly selected students. All right, so we randomly selected 200 students and we created a 95% confidence interval. And we have 200, we created a confidence interval from those 200 students, a 95% confidence interval, and we create another one, and create another one, create another one. 95% of those intervals should contain the true proportion of pet owning students at CSU Stan. All right, so that's what it means to be 95% confident. Another thing about confidence is that the greater your confidence, so like 95, 99%, right, 99.7, like the greater your level of confidence in your interval, the larger your interval is going to get. Think of it this way. I need to hit a target, right? The bigger the target is my, I want to be able to hit the bullseye, right? Or the target itself, the target is my true proportion. The bigger the target, the more likely I am to get it on that target if I just kind of threw it out there, right? So the bigger the interval, the more likely it's going to catch the true proportion, which means I can be more confident about that proportion. But if I said I'm only 50% confident, then that interval is likely going to be pretty small because I'm not as confident that I'm going to capture the true proportion. So, and then I'll talk about the margin of error in just a second. I want to kind of make it make sense to you because right now this is 2020. There's political stuff going on. We see political polls, and all those political polls that we see on TV, those are all confidence intervals. And really, they're a lot like a one prop z interval that have a margin of error, which means it could be, the true proportion could be anywhere between those values, right? And we'll take a look right here. So let's take a look at Geogebra. I don't want to spend too much time talking about that stuff. And we're going to go to Geogebra Classic. I like using Geogebra Classic. And we're going to go to probability. There are two ways that you can get to a one prop z interval here. But we're going to do it this way with z statistics. We're going to go to statistics. In the probability, you're going to go to statistics. In the drop-down menu, we're going to go z estimate of proportion. All right, so z estimate is using a normal distribution. A t estimate is using a t or a student's t distribution. For right now, we're going to use z estimate of proportion. My confidence level is 95. If I wanted to, I could change this. Okay, if we wanted a 90%, I can change it, but I have a 95% confidence interval. Now in Geogebra, I need the number of successes. I don't have that in my example. I have 5% of 200. So what I need to do is I need to do 0.05 times 200 to get the number of successes that I had in my sample. because that is what GeoGebras want. So that's 10. So I'm gonna say there's 10 successes. So I'm gonna go back to GeoGebra and put 10 in here. And my N is the sample size. My sample size was 200, and bam! All right, I'm gonna snip this bad boy here just so I can keep it in my. Oh man, it's not letting me snip it for some reason. It's being bad. Okay, so let's whatever. We won't snip it. We've got a standard error. The lower limit's 0.0198. Okay, so 0.0198 is my lower limit, and then my upper limit is 0.0802. Look, it nicely gives us the interval right here as well. All right, so this right here, you see this guy right here, 0.0302. That's called my margin of error. All right, my margin of error is right in between. It's how far it is from my my sample, my statistic, which is the right in the middle, 0.055%, which is what I had from the p hat, what we call p hat. Okay, so we got 0.0802. All right, and it did give us 0.05 plus or minus my margin of error. What was that again? Again, I wish I could have just clipped that. 0.0302. All right, this is the margin of error. Okay, margin of error basically means I can go up as high as 0.05 plus 0.03, which is 8%, right? These are percentages, by the way. So this would be 1.98% to 8.02%, right? I'm going to write that out in just a second. So my margin of error tells me on the high end and the low end where my true proportion might lie. So what I'm going to say here is that I am 95% confident that the true proportion of pet, or the population proportion of pet owning students at CSU Stan, so the population, what I really think is going on in all of CSU Stan is that somewhere between 1.98% and 8.02% is what the true proportion of students that own a pet at CSU Stan is. So that would be my interpretation of the confidence interval. Remember, we want to go from the low end to the high end. So again, we're going to say I'm 95% confident that the true proportion of pet owning students at CSU Stan is between 1.98% and 8.02%. And that includes my margin of error. And if I wanted to, I can report that my margin of error is 0.03. Well, what I usually do is I report my margin of error as being 3.02%. Okay? Now, what happens in like political polls is they'll give you this number and they'll say, in a survey done of randomly selected people, 5% say that, 5% say they own a pet. And then they'll say 5% own a pet, own a pet. And then they'll say at the bottom in little tiny letters, they'll say margin of error is 3.02%. And so you got to have to do the math to say, it can be as high as 8 and as low as 1.98. Now, that's saying that anywhere in there could be the true proportion. It could be 2%, could be 8%. I don't know. It's somewhere in there. But we're 95% confident that it's somewhere going to be in between 1.98 and 8.2. I think I repeated myself over and over, and hopefully you understand what I was saying. But the gist of it really for this video was how to use GeoGebra. All right, so this is how the GeoGebra output looks. And the last thing I want to say before I let you go from this video is that you need to remember that you need the number of successes. So if the problem gives you the number of successes, you know exactly the number, you put it in there. If you don't know the number, then you're going to have to multiply the percent. Now, sometimes if you multiply the percent, it's a decimal. You cannot put a decimal. Well, I guess you can put a decimal in GeoGebra. I was going to say that you can't, but you can. And it'll give that to you as well. So just remember that you have to put in the successes. You cannot put 0.05. If you did this, you'd end up with the wrong, like this is the wrong answer. So just because the problem said 5%, you can't put 0.05 in here. You need to put the actual number of things. That's why I multiply 5%, 0.05 times 200. All right, that is it, folks. That's how you use GeoGebra to find a one prop z interval. That was a much longer video than I needed to make, but hopefully you got what you needed. All right, put me on 2-speed next time. We'll talk to you later. Bye.